We are 30,000 plus employees strong, bright minds working together, making the connected world more secure, safer, better. Your edge devices perform better and last longer thanks to us. Who are we? We are NXP.
Hello Taiwan, and a very warm welcome to the Computex 2022. I am super excited to be with you today, but honestly I'm at least equally excited that I had the chance to bring a couple of friends along, and you might see this here. The simple reason is that after more than 2 years of continued lockdown period in the country of our headquarters in the Netherlands, it is now for a few weeks that we have started here in Eindhoven to be in a position again to have face-to-face meetings, to see people in person, and actually to unlock all that energy which we couldn't for 2 years. And for me, that's a very, very inspiring moment. And I'm super happy I can share that with you in Taiwan today. We are here to share quite a few things, all the way ranging from the more recent customer and partner announcements which we've done, all the way to opening the kitchen, the kimono a little bit more, and have you look into what's cooking from an innovation perspective for the secure connected edge in NXP. Now, I'm not going to do this alone. It's all about teamwork, and we are still half virtual. So I have Amanda and Raphael joining me from Austin in Texas today. Amanda is going to dive deep into what our connected edge solutions will do to facilitate best possible experiences in the connected smart home. Raphael, and most of you know him very, very well, will continue to push the boundaries of connectivity. And connectivity is so important for consistent experiences, consistent consumer experiences at the edge. You don't want to be frustrated about losing connections, about different standards which don't work with each other. And Raphael is going to speak about, amongst others, the Tri-Radio, which is a world first from NXP, which is integrating Wi-Fi, Bluetooth, and the new Matter protocol, which is a common language for smart home standards. But also here in Eindhoven, we have Huan Yu and Brian joining us. And Brian is going to dive deep into vehicle networking, into the power of gateway chips, which allow for over-the-air updates, unlocking the world of services into the automotive world. And Huan Yu takes it a step further when we think about more and more automation of driving. NXP is the world leader in automotive radar. Now we push the envelope by going to what we call imaging radar, which gets us into totally new levels of resolution capability, and with that of the capability and power of radar to be a true enabler for automated driving for levels 3, 4, and 5. None of these innovations is possible alone. We have a major set of opportunity ahead of us in the industry, but also significant technology and ecosystem challenges. So the collaboration between companies, between suppliers and us, between customers and us, but also between peers and us and other partner companies is of the utmost importance. And here Taiwan plays an absolutely outstanding role. And I want to briefly walk you through 3 partner examples which really excite me because I know we jointly make a difference. And the first one obviously is TSMC. NXP has had for many, many years a very yielding, trustful, powerful collaboration with TSMC. I'm actually glad to say that the announcement I made on this stage a year ago about production readiness of our first 16 nanometer automotive products in 16 FinFET technology from TSMC that has yielded by now in full volume production of both products, which is a leading radar processor and which is a gateway chip for the cars. I felt strong about that. C.C. Wei, the CEO of TSMC, felt strong about that. But I feel much stronger that today we take it a big level forward. Because what I'm showing you here is world's first 5 nanometer test chip. Fully automotive compatible. It is our S32N test vehicle in 5 nanometers from TSMC. It's the first design of NXP in 5 nanometers, and it's fully ASIL-D compliant. I will speak more later about the role of functional safety for robotic systems, and to my best knowledge, this is the world's very first chip which combines leading-edge semiconductor processing technology, 5 nanometers, and full ASIL-D capability. So there aren't many of them yet, so I was about to slip it into my pocket, but I put it back for now. So this really marks a major leap in innovation. But it's also about the ecosystem. And the next leading partner from Taiwan I want to speak about is Foxconn. We've all known Foxconn as a manufacturing leader, a leader when it comes to being efficient, when it comes to being fast in the mobile and computing world. Now there has been a lot of success together in those segments between NXP and Foxconn, but we decided jointly to take it a step further. And that is because the automotive industry offers great new opportunities given its transformation. We know about electrification, we know about connecting cars to the cloud, we know about autonomous driving. All of those are very disruptive changes of the automotive industry, allowing new entrants to make big steps forward. And this is the ambition of Foxconn. And NXP, as a long-standing leader in the automotive semiconductor industry, is actually partnering with Foxconn to make that happen. I believe the auto industry has to become faster, has to become leaner, and this is our interest, our NXP interest in that partnership, which focuses on smart car access systems, electrification systems, fusion control systems, etc. So I'm very proud about the fact that NXP is now together with Foxconn making a new leap into automotive. Now the world is much more than automotive. And one of the big waves which is going on as we speak here is the deployment of 5G networks. And NXP has also been a long-standing leader in mobile network deployment. And I'm glad to say that Compal is leveraging the Layerscape digital processing leadership of NXP into its small cell integration. These are small cells which give much better network density in urban areas and crowded indoor spaces. This is where 5G still needs a boost, and our Layerscape processors, together with the integration performance and capability of Compal, makes all of the difference here. So thanks to Compal for working here with NXP. Now, I talked about the relevance of ecosystems. The relevance of ecosystems to collaborate and actually tackle challenges which no one alone could do. Now, I admire Taiwan's ecosystem. It's much more than TSMC, Foxconn, and Compal. It's a much bigger system of companies. Thank you. And again here, this is not complete, but I just wanted to give a flavor with how many more Taiwanese leaders in high-tech NXP is collaborating to actually advance our world. That is very, very satisfying. Now, all of this is to the backdrop of a pretty challenged industry over the last 2 years. So let me zoom out a little and share some reflection of what has happened to the semiconductor industry over the past 2 years. Pretty much after the pandemic was hitting the world in the beginning of 2020, the demand for semiconductors saw an unprecedented growth. I would almost call it an explosion of demand. Now, the way how we think about this is it is just an acceleration of the deployment of edge computing, which we had foreseen anyway. It just came much faster and much earlier, partially due to the remote work from many, many people who needed laptop computers, Bluetooth equipment, etc., but also many, many other trends there. The matter of the fact is, due to this, until now, the demand for semiconductors worldwide is surpassing the supply capability of our industry. Now, our whole industry, including NXP, including TSMC and many others, we have worked and we keep working very hard to get as much supply online as possible. Demand keeps going faster. While this is a stressful supply period, there are two other implications which I think are much more relevant and which are much more important for the future of our industry. The one is that society at large, many governments, have only now realized how critical semiconductors are for anything which has to do with the digitalization of the world. And that is why Joe Biden, for example, in the United States of America, explicitly calls semiconductors a critical part of the critical infrastructure of the United States. And that led to the CHIPS Act in the US. A few weeks later, it led to the CHIPS Act in Europe. And what this is all about is public interest, but also public funding of both manufacturing capability as well as R&D and innovation for the global semiconductor industry, which is a great move because I truly believe that microelectronics, so the combination of semiconductors and software, can make, will make, and have to make such a difference to the world going forward. The other implication is the way doors got open for us, for NXP, to work with our OEM customers. What started in 2020 as stressful, eventually painful supply discussions, in most cases has morphed by now and evolved by now into still discussing supply, but actually building on that relationship for strategic innovation collaboration. I would say I've never seen in my career any period where we have so rapidly moved so much closer into customer strategic relationships to actually work on innovation for the next 5 to 10 years, not for the next few quarters. And I would like to briefly give you a handful of examples, what that yields, because I find it truly remarkable. Think about Volkswagen. We all know Volkswagen's absolute mission in life is move from combustion engine to electric vehicles. The whole company is in transformation. Now, Volkswagen has this one platform strategy for electric vehicles, which is called MEB platform. That's a horizontal platform cutting through all the electric vehicles across the company. And NXP is the unique partner for the battery management systems across all of these cars sitting on that platform. So our microcontrollers and high-precision analog front-end chips are in the ID.3, in the ID.4, in the Audi e-tron, in the Porsche Taycan, and all of these upcoming models from Volkswagen. So that's an extremely strong proof how this partnership has shaped up through a difficult period. Not different with Samsung. We, together with Samsung, brought ultra-wideband to life in mobile, into automotive, and into Internet of Things applications. So to be more specific, our ultra-wideband radio, the associated security chips, the associated middleware is sitting in Samsung smartphones, connecting to smart tags, which, for example, help you find your briefcase or your keyring, but it also helps you open cars. So Hyundai just came out with new cars which can be opened with a Samsung smartphone. So that's a whole new world of use case, starting from the mobile world, reaching into IoT and automotive. Talking about automotive, we are also very proud that just before year-end last year, we announced together with Ford Motor Company that our i.MX8 applications processors and our S32G gateway processors are at the heart of their most iconic model, which is the Ford F-150. This is probably the heart and soul of the Americas. Also the Ford Bronco, the Ford E-Mac, which is a new electric vehicle, they all share this for infotainment and in-car experience applications on the i.MX8, and for over-the-air updates based on the gateway S32G. We will speak more about that later. But mind you that over-the-air updates for cars are a revolution. The innovation cycles, the user experience you have as drivers gets into a totally new pace if by software you can refresh the car during its lifetime. It's not frozen and stuck with the innovation which came with it when it was shipped to you, but it can actually be renewed. And that one gateway of the software coming into the car, being certified, being checked for security, that chip is from NXP. And one other company which is very deeply involved with NXP in this is Amazon Web Services. Because the cloud connectivity of cars is not only going to be about over-the-air updates of the in-car system, but it also allows a lot of new services. Off-board navigation services, maintenance services, etc. And Amazon Web Services has discovered this as a new field of business. And again, NXP, since we are playing in all of these sectors, has helped to collaborate here. And we are proud now that the Amazon Web Services engine is running on our S32G. Now, I left out Microsoft because that is probably the most powerful one on the long run. Microsoft's cloud services are very, very strong. But they only get to life, they only get to us as people when these cloud services are deployed to edge applications. And these edge applications are running on our i.MX8 and i.MX9 applications processors. So we have ported the Azure Sphere software from Microsoft on these processors, such that we have a massive deployment now together with Microsoft into the field to let people enjoy the Microsoft Cloud or the advantages of the Microsoft Cloud services into edge applications. So lots of good stuff, and all of that, mind you, during the period of the pandemic, where people could not meet in person. All of this is about innovation, about collaboration, and in the end, applications which are driving the semiconductor market growth. My conviction is that the next decade of market growth for semiconductors comes from edge processing. And let's put this a little bit in perspective. The semiconductor market, which last year, the year before, was like $500 billion, has grown in long waves. And those long waves have been enabled and unlocked by massive application development of new things. Between 2000 and 2010, it was really about laptop computers and gaming. Between 2010 and 2020, it was about smartphones, tablets, and the rise of cloud computing, data centers. And I think those next 10 years, between 2020 and 2030, it will be about edge computing, edge applications all around us, complementing the power of the cloud. And that is where I am deeply convinced NXP is going to emerge as an incredible leader. People always want to have numbers. Some market researchers say it's going to be about 75 billion smart connected devices by 2025. I think they only say this because you can easily remember. 75, 25 feels like a good fit. The reality is we all don't know. Maybe it's already in 24, maybe it's only in 26. But the matter of the fact is, it is an explosion from a growth perspective. It goes very, very fast. And it goes very fast because it spans the different parts of our life. If we consume, if we pay, if we move, if we interact, if we work, all of that is enabled by edge applications. And that is why the numbers are growing so fast. Now, the one way to think about this from what it will do to the world is anticipation and automation. Technology around us will start to anticipate what we want to do next. It will make proposals. It will make offers to us. And through artificial intelligence, it will learn to do the right thing. And I can promise you, you will be positively surprised how well all of these applications will read your mind and will know what you want to do next. That's the anticipation. The other one is the automation. And that's, from a technology perspective, it's about robotics. And it's very close to us. Think about the vacuum cleaner. I'm sure many of you have this automatic vacuum cleaner in your house, or the lawnmower. It's in the end, it's a robot. Now, the ultimate part of this is probably an autonomous car, but it's always the same concept. Technology is automating simple tasks and more complex tasks. Now, the challenge with all of that is it needs to be consistent from the experience which we have as people. I think I mentioned earlier, nothing more frustrating than if you try to do your first things in exploration of a smart home, and every device has a different connectivity standard, and it just wouldn't connect. Super frustrating. Throw it away. But it also needs to be safe and secure. Everything that is connected is open to cybersecurity risks. And it needs to be safe, and I think the easiest way is the car to understand that thinking about an automated car is a good idea, but definitely it should enhance safety. It shouldn't pose additional risk. So safety, security, and consistent consumer experience is what we have to deliver as an industry. And the way NXP has been created, how we have crafted our portfolio, is following those requirements. We have 4 unrivaled technology pillars, which are strictly following the signal chain of every edge application: sensing, processing, connecting, and actuating. Through organic moves, through acquisitions, we have built an unrivaled portfolio across all of these 4 pillars. And you will get more deep dives in the next minutes on them. But that is only the foundation. The cream on the cake is complementing this with functional safety, cybersecurity, and more complete system solutions. I talked about the role of cybersecurity. I simply believe there will be no connected applications if they are not secure. I talked about safety, and those 2 are deep in the genes of NXP. You know our history in cybersecurity. We have made mobile payment work. We have made electronic ID cards work. That is all about security, deepest levels of security. And now we are bringing this out into many other edge applications. They all need different degrees of security. And it's no different for safety. NXP has been a long-standing leader in automotive safety systems, ABS, airbags. And there is a system concept called functional safety. And again, we are evolving this now into industrial automation applications and other applications which need similar levels of safety. This is why I'm so excited that this 5 nanometer test vehicle is ASIL D compliant, which is the highest level of ASIL D safety. And then finally, system solutions. The nature of these edge applications is that many machines, and with that many companies, are suddenly exposed to highly complex technology solutions. I think a company which did a vacuum cleaner 20 years ago wasn't particularly deep into electronics. Now this becomes a connected edge application, which has to work with connectivity, with security, etc. And that is why NXP has this complete portfolio to offer solutions which cut down the time to market and the R&D efforts, and I would say the general hurdle to do these applications from our customers' perspective. And I personally know that also a lot of customers which we have in Taiwan are actually enjoying that advantage, that benefit, which NXP is bringing to the party. Here I want to move from theory to practice, and I actually switch over to Amanda in Austin, Texas, who is going to give us more specifics about what our edge applications are doing to bring consistent experiences to life in the smart home. Thank you.
As more devices anticipate and automate to meet our needs, the expectations for consistent experiences will soar. Here in the smart home, we've come to expect conveniences already. We can control all kinds of devices remotely. We can even use our voice for hands-free control. But what can we expect from a smart home that's safe, secure, and sustainable, where our devices and our homes are good for the environment, good for the humans, and even our pets? One where my dog can be tracked with a smart collar, and here outside where my garden can be equipped with an irrigation system that takes into account the types of plants and local weather for precise water delivery. Soon our homes will become occupancy aware. It will start to understand my patterns and behaviors. It will know when I've left or arrived, and it'll adjust lighting and temperature to my preferences. My refrigerator will become even smarter, alerting me of food I need to eat before it spoils. And built-in preventative maintenance will help expose any issues before they become unfixable, and this will help keep appliances out of the landfill. The key to enabling all of this is edge processing and artificial intelligence. It's what we call the intelligent edge. We also get faster real-time response. With the edge, you don't have to send data back and forth to the cloud for processing. The machine learning and data processing is all done inside of the device, and that saves energy. With the intelligent edge, we can also help keep our homes and us safer and healthier. Our air quality can be monitored, and we're alerted to change the filters. We can also monitor water quality, so we know what's coming out of our tap is safe to drink. More people are making conscious decisions to stay in their homes as they get older. Using connected lighting and other sensors, a person's activity can be tracked. If they are not active with their daily routines, remote caregivers can be alerted. Let's explore how edge processing can be applied to one of the most familiar areas of the home, the bedroom. By looking at a leading smart bed, the Sleep Number 360 smart bed, we don't typically think of a bed as a high-tech zone, but Sleep Number is changing that. Understanding what happens when we sleep is critical to maintaining and improving our sleep and for our overall health and well-being. Until recently, we've relied on overnight stays in a sleep lab to understand what happens to our breathing, our movement, and our heart rate. But we've entered the age of the smart, connected bed. Enabled by AI and machine learning, the sensors in the 360 smart bed measure heart rate, breath rate, motion, temperature, and more. This allows the bed to learn and evolve with each sleeper. The sensors help to create a responsive and adjustable microenvironment for each person. Because of edge processing, a smart bed can respond in real time to a sleeper to keep them comfortable. It delivers highly accurate monitoring and personalized insights. And it may eventually be able to identify health risks. Smart beds can enable preventative, proactive healthcare from the comfort of your own bed. Since smart home devices collect very personal information, does that mean we have to choose between privacy and convenience? Just because a device is connected to the cloud, no one should have to give up their privacy. Because the processing is done closer to where the data is being collected, the private data can stay near the user, And even if information is sent to the cloud, the application can be designed to not include personal information. As these devices become more integrated into our daily lives, we must ensure consistent experiences that are safe, secure, and energy efficient. It's a focus at NXP, and we're thoughtful about what we build. The latest IDOMX9 series of applications processors are our answer for intelligence at the edge. A balanced combination of sensor interfaces, secure and reliable compute, a range of performance options, and machine learning acceleration are needed to deliver the optimum smart home device.
As you've seen, advanced processing has made our homes more responsive. It's opened new ways to improve our lives by making our home devices more convenient and efficient. As a technology innovator, we also spend a lot of time asking ourselves, but what comes next? How can we continue to push the limits of convenience? How can we provide the foundations to make today's good user experience great? And this is where we believe new wireless technologies, all of them working together in unison, will not just unlock the full potential of the smart home, but push the user experience to new levels. Yes, we can make all the devices work seamlessly together, but why stop there? What if we could make them aware of the location of other devices? What new user experience can we unlock? What new use cases can we create? One of the biggest innovation barriers in the home has been the fragmentation and complexity of connectivity. As consumers, we have all been frustrated with our smart devices. Our less than ideal experiences have been a byproduct of the use of a patchwork of different ecosystems and a slew of new and old wireless protocols in our smart home gadgets. This has made it difficult for all these smart home devices to seamlessly work together. We don't want to think about ecosystems or how technology works. We expect all of this to just work, and it should. Now, the good news is that thanks to a new universal language called Matter, one that is backed by companies such as Google, Apple, Samsung, NXP, and many others, we're finally on the verge of true interoperability in the smart home. NXP has all the technology building blocks to enable Matter in all devices. We help developers overcome the connectivity challenges they face. And coexistence and interoperability are two of the biggest ones. Our latest connectivity solutions are really a game changer in that respect. Earlier this year, we announced the world's first secure tri-radio combo solutions that can simultaneously transmit and receive across Wi-Fi 6, Bluetooth, and Thread. This new family of wireless solutions should quickly become the de facto connectivity solution to drive seamless operation and the right consumer experience for the smart home. It is perfect for border routers and gateways bridging Wi-Fi and Thread-enabled Matter devices for local communications or the cloud. We've done the hard work for developers by delivering the best wireless coexistence across these three key radios. We're ensuring optimal throughput and performance to satisfy even the most advanced use cases coming to the home. But our groundbreaking innovation didn't stop at coexistence or integration. We know that once in the field, security is fundamental. Devices are increasingly more susceptible to a wide range of logical and physical attacks, including malware injection, theft of our encrypted data, malicious software updates, even reverse engineering. This is why we designed our new family of tri-radio solutions to also be the industry's most secure wireless MCUs. We have integrated a high-performance MCU with an advanced security subsystem, all in a compact and cost-effective SoC for developers. Our tri-radios offer the best front line of defense to IoT edge devices and a platform of trust for developers to design IoT applications with built-in security. And the cloud infrastructure, NXP Edge Lock to Go, to securely deploy and maintain the product over its life cycle. As we map the future of connectivity and seamless user experiences, we turn our attention to adding a new capability to smart home devices: sensing. 2 years ago, we launched our Tri-Mention family of ultra-wideband solutions to enable, for the first time, sensing with spatial awareness to smart devices. And this is the ability to know where an object is relative to oneself. Devices have now the power to determine the position of trusted devices to the centimeter level. By extending this capability to every person and devices in the home, we can now enable the smart home to identify who you are, exactly where you are, and then react, anticipate, and deliver a customized experience for you on that room for that device. But UWB has even more to offer. Today, we announce radar for our UWB solutions in mobile, IoT, and automotive. And this introduces new exciting capabilities of motion sensitivity and gesture recognition. Katie, load up. The combination of UWB ranging and radar makes UWB the closest thing of giving objects intuition. Devices can now detect presence and even monitor your vital signs. The UWB pulse radar is so precise, it can detect the respiration rate of a child or a pet should they be left inside the car. This new light detection feature will improve automotive safety. And it is yet again another example of how we at NXP are both anticipating and accelerating the connectivity breakthroughs for our customers.
Welcome back to Eindhoven. And we have moved in the meantime to our innovation lab. You can see some of the demos here around me. The one closest to me is actually a car. And what you see symbolized here is all of the data traffic in a modern, very much electronically driven car. And that data traffic is massively increasing. We think that a car is going to generate something like 10 terabytes of data in a few years from now per day. And on that same day, it will have a need to transmit and receive another 50 gigabytes of data. So obviously, the structuring of that data and the topology of the data network in the car needs rethinking. And that rethinking has been led in a transformational way by NXP. And I feel we had the entitlement to do this as the global #1 semiconductor supplier for automotive microcontrollers and microprocessors. So we've worked hard with our customers, the global automotive industry, to move to what we call the domain structure, which is a more hierarchical network topology with very powerful domain computers. And at the same time, we've worked very hard to make sure that the cloud connectivity becomes reality. So connecting that complex system at one point, which is the gateway chip, over the air to the cloud, including the required cybersecurity and including everything it takes to transmit and receive that massive amount of data in a secure way to renew the systems, all of these complicated systems in the car at one go. And our way to facilitate this is our S32 microprocessor platform. It is a dedicated automotive platform which has been designed for highest levels of reuse of software. Given this complexity, the biggest headache of our customers is the software development. So it is of utmost importance they can reuse as much software as possible from one generation to the next one. And this is why the philosophy of our S32 platform is that from one generation to the next of our microcontrollers and microprocessors, we are using the same software environment. Starting from 40 nanometer generation, 28 nanometer generation, 16 nanometer, I mentioned earlier today the radar and gateway processors, which are now in full production, all the way down to 5 nanometers, which I proudly showed earlier today. And now let's hear what Brian has to say about how we are successfully deploying that product to our customers.
Hello in Taiwan from Eindhoven. I wanted to give you an update on the announcement we made last year at Computex about the 16 nanometer S32G for automotive processing. So I have some great updates. I want to talk about the value we're providing to customers and talk about a couple examples of those customer success stories in Taiwan and China. So the first thing is S32G processors. What are they about? S32G processors really fit a sweet spot between the traditional microcontrollers and application processors. They're leveraging the technology and expertise that NXP has developed over decades of automotive, enterprise, networking, and security, and bring those all together in one chip. And that's important because the new applications in these vehicles requires that level of integration for the success of these new types of vehicles. The S32G processors bring together not only real-time processing and application processing, but they layer on network acceleration, security, and the highest level of safety, ASIL D support. So together, the family supports a wide range of applications. We've extended that recently with the S32G3 family we sampled in November that allows us to take it to the next level of performance and address even new higher performance applications that are required for the next generation of intelligent vehicles. So the diversity of this part has been amazing through this last year. This has been known as the S32G for gateway, but it goes way beyond gateway. We're seeing this being used in domain controllers, zonal controllers, and even safety controllers within ADAS and autonomous drive systems. It's providing a lot of value. But what really excites me about the S32G is that it's not just a part moving data or processing data. It's providing real experiences. It's providing opportunities for OEMs to generate new forms of revenue, to reduce the cost of operations, and to provide users with enhanced experiences. We're also enabling the next generation of vehicles, which require a lot of consolidation of functions. And what's going on is we're moving from a hardware-defined world, which is based on ECUs or boxes within a vehicle, to a data-driven, software-defined world, which gives us the opportunity to create new opportunities and experiences. And ultimately, being able to do over-the-air updates of vehicles, which allows us to enable connected, intelligent vehicles that get smarter over time. They get better with security, safety, new experiences, and ultimately provide more value to customers. So NXP delivers more than silicon. We invest in customer enablement. We actually introduced a gold box. This is a hardware reference design that allows our customers to very quickly develop their own products. On top of that, we've introduced the Gold VIP, which is a software reference platform. Together, it allows our customers to develop products very quickly. And that is supported by a global network of ecosystem partners that allows our customers to be able to move very quickly with this product. This product is targeted for automotive, but we've seen a lot of success with it in other markets, such as industrial and transportation, that see the value of this type of processing. And S32G processors are widely available through distribution. So this is a mass market device beyond just automotive applications. S32G processors have gained global acceptance by automakers. And we've publicly announced Audi and Ford as using S32G processors in their vehicles. But what I want to talk about today are what Chinese and Taiwanese automakers are doing with S32G to transform their vehicle architectures and provide new value to their customers. The first one is GAC Motor. GAC is based in Guangzhou, China. And they are an exciting customer to me because they started with S32G, were able to move very quickly and go into production vehicles. In fact, the first production vehicles with S32G in September of last year. Now they've taken that to provide initially over-the-air updates to make their vehicles more attractive, to provide more features, but they've taken it to the next level. They've leveraged the S32G3 and they're designing their next generation architecture with it to consolidate a lot of the functionality, to simplify their networks, to lower their weight, their cost, and at the same time, providing more benefits through the lifetime of the vehicle for their customers. So we look forward to further collaboration with GAC to be able to provide more benefits to both GAC and their customers. Another great example of how NXP is working with automakers is a great example right here in Taiwan. with Foxconn. And Foxconn is a joint venture between Foxconn and Yulong Automotive, an automotive OEM here in Taiwan. So together, they created a Model C all-electric SUV, and it's based on S32G in various places to provide value proposition to both their partners and their customers for these new open EV platform. NXP is excited to play a key part in this effort to provide the processing platform, the automotive capabilities to drive EV platform innovation. So I hope you're able to gain some interesting insights and see how the S32G is providing value globally and especially here in China and Taiwan. If you found this interesting, we'd love to have a conversation with you of how we can help you transform your products with S32G processors too. So I touched on functional safety with the 16 nanometer S32G device from an automotive processing perspective. We have the 16 nanometer cousin to the S32G, the S32R. So Wan Yu is going to give us insight into how we extend functional safety across the vehicle to the imaging radar capability that NXP offers too.
Thank you, Brian. Modern cars are amazing. They've greatly enhanced our in-vehicle experiences, providing more driving comfort and enjoyment on the road. Yet, no matter which way you look at it, mobility, getting people from point A to B safely, will always be at the core of automotive development. And it is easy to understand why. Each year, more than 1.3 million people die in car accidents around the world, and many more are severely injured. And even worse, many of the accidents are due to human error and are preventable. Through the development of increasingly autonomous vehicles, the industry aims to reduce these numbers by moving more of the responsibility for driving into the vehicle. As a result, we are placing more of our trust in vehicles, and it is therefore essential that we deliver a consistency of safety experience across the vehicles. And thankfully, there are more advanced driving features in vehicles every year, spurred by new legislations, standards such as those of NCAP, and that aim to enhance the safety of vehicles through applications such as blind spot detection, automatic emergency braking, and vulnerable road user detection. So in fact, by 2024, over 60% of vehicles will have some sort of advanced driving assistance features, and radar plays a key role in realizing these ADAS features, because it allows the vehicle to travel safely in environments where the driver has a hard time seeing, such as in the rain, fog, or low light conditions. And over recent years, the automotive industry has recognized its great potential to enable higher levels of autonomy, and at NXP, we offer one of the industry's broadest portfolios of radar solutions, from single chip that combines sensing and processing to the latest radar transceiver and processor chipset for 4D imaging radar. 4D imaging radar redefines the way vehicles understand the world around them by creating a high-resolution point clouds like this. That enhance the detection and classification of objects, enabling cars to drive through complex scenarios such as dense urban environments with more sophisticated and reliable automated maneuvers. And NXP is instrumental in delivering imaging radar solutions that enable a broad mix of vehicles to benefit from this life-saving technology. So what is a 4D imaging radar, and why is it important? 4D imaging radar expands radar's capability from measuring range and speed of objects with the further dimensions of azimuth and elevation angles. Let's start with azimuth. The azimuth angle measures how far objects are to the left or right of the radar. So when multiple objects are in close proximity to one another, imaging radar provides a sub-1 degree azimuth resolution, so that objects can be seen as separate from one another. And this is key for the vehicle to detect, say, a motorbike far in the distance driving the same speed next to a truck. And this is challenging even for us human drivers under poor weather conditions. The elevation angle allows to calculate the height of objects so that the vehicle can make critical decisions, such as if an object detected is safe to drive over, or if a road tunnel ahead is safe to drive through. With such, together these 4 dimensions enable modern cars to provide more complex autonomy features, such as highway chauffeur and urban pilot. Radar is not an island solution. It needs to scale across a wide range of use cases. NXP's radar product family is built on a common digital processing architecture to enable synergies across use cases. NXP's imaging radar is an essential part of this scalable family. Here you see a 4D imaging radar sensor powered by NXP's radar chipset and co-developed in conjunction with our Taiwanese partner Computex. The sensor contains NXP's new purpose-built S32 R45 imaging radar processor and 4 cascaded TEF 8200 radar transceivers. This chipset combination doubles the RF performance and delivers up to 64 times the compute performance of standard processors for enhanced sensing. So what is it that makes NXP's 4D imaging radar solution compelling? It delivers sub-degree fine resolution, that is true, but high-resolution sensors on the market can already do it today. However, these sensors often sense over one particular range. And as cars will have to support more demanding autonomous driving scenarios, it is essential that advanced sensors can deliver the always-aware type of sensing that goes beyond a single-mode operation. And this is where NXP's imaging radar is special. It delivers 3-in-1 sensing across short, mid, and long range concurrently, with configurable field of view, or with one set of hardware and no mode switching. As compared to the other solutions on the market, which could have more than 2,000 antenna channels, NXP achieves this with only 192. And this is made possible by maximizing the efficiency of all available antennas, driving all transmit antennas simultaneously, and then accurately separating them on the data, all the data on the receiver side. Special waveform coding schemes are essential here, and this is where NXP's premium radar SDK can contribute significantly. It provides software solutions for MIMO waveform optimization, as well as methods to enhance radar resolution beyond the physical limits imposed by the antenna design. As you can see, imaging radar brings additional safety to the roads by enabling the detection of smaller objects with improved classification in the distance of up to 300 meters and providing enhanced environmental mapping and scene understanding. NXP helps to deliver consistent safety experiences with its rich radar portfolio and stands firmly in bringing innovative technology to make our future roads safer.
Thank you very much, Huan Yu, for walking us through the amazing performance power of imaging radar. For me, it is fascinating to see how it really can turn such a car into the position of anticipating and automating. Anticipating any possible traffic hazards. Think about a kid just running behind the car on the street. The imaging radar is going to catch it. And then automating the car's reaction at light speed, pushing the brakes, turning the steering wheel, better and faster than we human beings could ever do it. This is what I meant when I spoke about our vision to drive anticipation and automation at the edge. And by the way, I feel imaging radar really comes to performance levels which will probably be bad news for the people doing LiDAR. Now, I think the same holds for Amanda, Raphael, and Brian when it comes to how they were in a position to let us feel what consistent consumer experiences actually mean. How our technology, how NXP's technology gets it to life. Seamless experiences in the smart home and beyond. And that comes back to what my vision is for NXP and our high-tech industry for this next decade. It is about bringing to life the power of the edge, of the connected edge, and of the secure connected edge. Consistent consumer experiences which are safe and secure at all times. And personally, I'm so much looking forward to collaborate with many of you also personally to make that work. We are well on the way, and I have all the ambition and all the confidence we're gonna do a great job together with that powerful ecosystem here in Taiwan. Thank you very much.